So the thing that separates a scalar quantity from a vector quantity has to do with the sorts of information that each of them is describing. So scalar quantities, right? Basically, they're just overarching categories that we can use to assign to a particular quantity or variable. So we've got all these different things we'll be measuring throughout the year in physics. We have things like position, we have time, velocity, force, momentum, energy, right? All these things are different physical quantities that we can measure. So our quantities that end up being scalar, those are ones in which they only give us information about the magnitude of something. So this keyword magnitude basically just means the size of something. So some examples of scalar quantities would be things like we have time, we have mass, so if we're thinking about this, right, time, maybe you are holding a stopwatch, you hit start, you let it go for 90 seconds, and you hit end. So maybe we're at a time of, we'll call T for time, so we have time is 90 seconds. Our mass, maybe we have an object that weighs 100 kilograms. So we're thinking about this idea of magnitude, right? Magnitude, the size of something, is basically just telling us whatever this number is we've measured. So let's say like the magnitude of our mass, that's going to be our 100. The magnitude of our time, that's going to be our 90. So scalar quantities only have information about the size of them. What we'll find is there's no mention of direction. Right, you would never say an object has a mass of 100 kilograms to the right. Right, all the information, you're only worried about the size of the mass, it's just 100 kilograms. Our vector quantities, though, they're going to have both our magnitude as well as a direction to them. Right, so we want to know, is this object, if we're thinking about different types of example of these vector quantities, right, we're going to have things like position. We're going to have velocity. We're going to have acceleration, force, and then there's going to be a few other ones that we're going to introduce throughout this year. So if we think about this, right, we have to have a direction. We can either use like our cardinal directions of north, east, south, and west. We might just refer to something as moving rightwards or leftwards, positive direction, negative direction, moving forwards, backwards. But the key thing here is if we're trying to describe, let's say maybe an object's velocity, we might say our object is moving 65 miles per hour going north. Right, so the fact that we have that extra little bit of detail here, right, the fact that we have a direction given as well, right, our car, it's not just traveling 65 miles per hour, it's actually going 65 miles per hour going to the north. So that key direction information is what's going to determine that things like velocity are going to be vector quantities.